So, hey, we're starting chapter 8, and we're coming back to our friend that we haven't talked, well, we have talked about it, exponential equations. And if you recall, we talked about in, I think, was it chapter 5? We looked at situations that involved exponentials and geometric sequences specifically. So, like if I was to insert a table here, we can talk about Lenny and George and their rabbits. So at month 0, I think they started with 2 rabbits, and then at month 1, each pair, it said this one breed, each month, each pair had a pair of rabbits. So if I have 1 pair, I'm going to have 2 pairs, which means I'm going to have 4 rabbits. So I go from 2 rabbits to 4 rabbits. The next month, I've got 2 pairs, and each pair is going to have a pair of rabbits. So I'm going to go from 4 to 8. And then I'm going to go from 3 to 16. And then I'm going to go from 4 to 32. And we can quickly see, we're not seeing a lot of what's happening here. And that's because these are growing pretty fast. Remember in our friend Desmos, when I come over and hold this, when I hold the shift key down here, right, it allows me to rescale the y-axis so I can quickly see what's going on. And I might want to come down here and stretch out the x-axis too, so I can see. There, that's nice, right there. So I can see that I've got clearly the x-axis is the number of months. So at no months, right, at the very beginning of time, and then 1 month later, 2 months, 3 months, 4 months, etc., and how many rabbits I have. This was clearly a discrete situation because they were talking about at the end of each month, so after a full month. We weren't talking about time is something you can talk about, like half of a month and stuff. But the other problem was we weren't talking about parts of rabbits. So definitely it's a discrete situation where these points are the ones that make sense. Now we can come along and we can follow that up with a function. And in fact, we know for this particular one, my 0th term is 2, right? So y equals, my 0th term is the number 2. And every single month, I'm taking that 2 and I'm multiplying by another 2. So 2 to the x power. So there it is, right? This is the curve that fits the entire thing. However, it doesn't make sense for it to talk about the things in between those, because we don't talk about like 5.5 rabbits or 5 3/4 of a rabbits. They're just rabbits at the end of the month. So today we're going to start our conversation. We're going to circle back and talk about exponents, but we're going to start our conversation by looking at a pretty simple one, right? We're going to look at exponentials in the form y equals b to the x power. In fact, we're not even going to have a 0th term. So if this is the function we're going to start with, y equals b to the x, that means right now my 0th term is always the number 1. So I'm starting with you don't even see it there. If I wanted to, I could say 1 times b to the x, right? So I'm limiting myself so that I always have a 0th term of 1, but I don't need to put that 1 there. The other thing I want to do is I want to limit some of my this domain. I'm going to go from -2 to, I'll just go to no higher than 5 right now. And I'm going to go a step size of 0.1. There we go. So one of the things I want to look at the very beginning is just what kinds of curves, wrong window. What kind of curves are possible? What kind of curves are possible for different values of b? So let me scale this up a little bit more this way. There we go, that's nice. And we can see that this is kind of a boring curve, right? Because if you think about it, what am I doing? If b is my multiplier, it's what I'm multiplying by each time. If I keep multiplying by 1, it's always going to be the same number. In fact, I could go back to the negatives, and back here I'm just dividing by the number 1, right? So you can see it's just always the number 1. So that's one thing that's possible. Another thing that I should probably look at is what if b itself is 0? So as soon as I made b become 0, notice it's still okay to multiply by zeros, right? If you have 0 and you multiply by 0 and another 0 and another 0, it doesn't change anything, it's still 0. But notice that it took away this part of my domain. You can come on in. I'm sorry, my domain. Part of my domain went away because now I can't talk about multiplying by negative numbers. So, I mean, I can't talk about dividing by 0. That's what it is, because on this side I'm dividing by 0, so it's not there. So, okay, so what else is possible? So if I was to say, well, what about a multiplier of 2? Okay, we see that, right? Multiplier of 3, multiplier of 4. So there's all these different curves that are multiplier of 8. I can go to 8, right? It's out of that bounds. But I can have all these different values. Let's put it back at 2. So if I was to hit play and kind of look at a bunch of these different values here, you can see that for the most part, they're all increasing. But when I get into this range where b is between 0 and 1, right? B right now is less than 1. It's 0.6. Oh, and then at negative numbers, it went away. But as long as I'm bigger than 0 and less than 1, I'm in this situation where I've got these decreasing functions. So it is possible, right, with y equals b to the x to have decreasing functions. Those are where I have multipliers that are less than 1. It's possible to have functions that are increasing, that I have multipliers that are greater than 1. I can have a function that's not doing anything. My multiplier is 1, right? B is my multiplier. It is 1. And then the one thing that's kind of funky is having b's that are negative. Sometimes Desmos will show this, and I don't know why it'll decide sometimes to show it and sometimes it won't. And I don't know if I zoom in just the right way, it'll decide to show me things. But if you think about this, it's pretty funky, because if I'm multiplying by -1, this is a function that's going from, like, if I start with my first term being -1, then my second term is going to be +1. And then -1, and then +1, and then -1, and then +1. So it's going to do this thing where it just flip-flops up and down, positive and negative, because it's alternating with each new power of x. So we are going to restrict ourselves and not consider multipliers that are negative right now, but we are going to consider multipliers that are greater than 1, where we're seeing increasing behavior. We're going to consider multipliers that are between 0 and 1, right? Not 0 and not 1, but between 0 and 1, meaning it's going to create this decreasing behavior. And then we can see what happens if our multiplier is 1, and we can also see what happens if our multiplier is the number 0. All right, that's all I have today. Pretty short. Please start the section 8.1.1 review preview. On the Monday, Tuesday of next week when you come in, I'll have my spreadsheet ready, and I'm going to ask you to show me both of those. Please, as we're going through Chapter 8, just enjoy things, do these assignments as they're assigned, and you're just going to have a much better experience. That's it. Have a great weekend. I look forward to seeing you again soon.